Honorable Chairman of the session, Shri Ajay Gupta ji, my fellow speakers on the dais, and ladies and gentlemen. Good afternoon, everyone. First of all, let me express my gratitude to the President IPTA, Mr. Sanjay Singh, and his entire team for providing this platform. My company, Enviropol, has been working in the field of environment for last 19 years, primarily in sugar, chemical, metal, and oil and gas sector. Recently, we have started proactively engaging with the pulp and paper plants. This is our first interaction as far as IPTA is concerned, and believe me, I realize that IPTA is truly a professional association, because when the editorial board came to know and they preempted the potential of this new technology, which I am going to tell you today, they came forward and organized this presentation, or I would say orchestrated this whole presentation for this session. During the last 2 days of this session and listening to all the big shots of the industry, I realized that I think the pulp and paper industry is more conscious towards the environment as compared to many other industries. So today I am going to take you through a very innovative and patented technology called MEPA, M-E-P-A. I'll explain you what does it mean. And this MEPA, which can find a great potential, and I would say it can find a true potential in pulp and paper plant for combating the nuisance of air pollution on a longer term basis. But mind you, so far you have been, whatever you have heard since morning, those all concepts were already in back of your mind. So even if you have a half energy, you are already absorbed it. But this is a new topic, and I would expect everyone to have a little higher energy to understand this concept. So I take that permission from you. So my presentation would last for about 15 to 20 minutes, followed by Q&A session. And with the permission of the chairman, I would, in the end of the session, would leave you with a 2-minute message directly from Mother Earth through a audio visual. So I'll start my presentation, and the objective, of course, for this presentation is to leave you with a concept which can be applied to upgrade your existing systems, existing facilities, and to make you future ready, basically to meet the European standards to that level. So I'll start my presentation, and the concept is MEPA. Not running? I can change it from here? No. Yes. So MEPA, the full form is Maximum Efficiency Particulate Abatement System. And this is an innovative way of upgrading the existing ESPs in your plant. Some problem? This one, no? Okay. So when you come to the pulp and paper industry, there are basically three areas of concern where the air emissions are happening. The first area is your CPP, the captive power plant, which has a solid fuel mix. It is not one fuel, it is a mix of fuel which can have coal as well as the different kind of biomasses. The other field, which is the most notorious, is the chemical recovery boilers, and the third one is the rotary kiln. Yeah. And where do we stand as on date? If you look at the norms have come down and are going more and more stringent, and as on date, for the new mills, it is 30 milligram per nm cube. So today, our focus is going to be on particulate matter, but we are going to provide you with a technology which is upgradable even to contain the SOx as well as the heavy metals like mercury. So when I say the norms is 30 milligram per nm cube, everyone thinks that we have to achieve 30 milligram per nm cube to meet the pollution norms. But if you see the rider written in the norms, that 30 milligram per nm cube at 6% O2 on dry basis. So if you convert it and normalize on the actual operating conditions, considering 14% moisture in the flue gas and 7% O2, which is a normal case, this works out to only 20 milligram. That means actually in actual operating condition, we have to achieve around 20 milligram per nm cube, which is a area which need to be discussed. And if you look at the type of particulate matter in the industry, you find from the solid fuel fired boilers, you have PM 2.5, PM 10, and also the particles above than 10 microns. Also you have aerosols because of the drying process, you have blue hazes in the chimney. And on the CRB side, the chemical recovery boilers, I would call it CRB in short form in the subsequent CPP and CRB. So on the CRP side, the situation is more difficult because the particulate here are less than 1 micron in the form of fumes. And that fumes are generated from volatile of sodium and chlorides and potassium, and then it has chloride salts also, which comes in the form of fumes and generates submicronic particulate emissions. And also it is very sticky and hygroscopic in nature. So overall, if you look at the two stream of in the paper plant, then the solid fuel fired boiler, which are more easier to control, but CRB is a little more difficult to control. And most common equipment which is used in the industry is ESP, conventional dry ESP, electrostatic precipitator. And if you look at the ESP efficiency curve, the best ESP design, or I would say the most ESP which are available, have got a limited efficiency on particles below 5 micron. Above 5 micron, you get a fairly good efficiency, but when you come down to below 5 micron, the average efficiency works out to only 90%. So having now understood the concept, like we have some system already available, there are certain limitations on particles below 5 microns. So what to do now? So what is the solution? How to solve this issue? And here comes the technology, which is a combination of ESP plus EGB, which is called electrified gravel bed precipitator, and this combination is called MEPA. And if I take you, before I explain you EGB, I'll just give you a little calculations. Like there are pain points, consolidated pain points of the industry, and on the pain point, you have one major pain point is that all the ESPs are old, mostly designed for 150 milligram. The second pain point is that there is no space for upgradation or increasing the number of fields. There are limited spaces. And the third pain point, which is quite major, that you have the high emissions during soot blowing and also during wrapping process of the ESP when the ash is dislodged from this. Plus on CRB, there are other pain points, including the pain point related to the nature of the dust, very sticky and very, very fine. So these pain points, if you combine together, you understand where do we stand as on date and where we have to reach. You know the limit, 30 milligram we have to reach in near future. So what should we do? Now, if you quantify this all need, if I establish this need, then presume that 10,000 milligram on an average basis is the input dust concentration from the boiler, right? Out of 10,000, 10% particles are below 5 microns. That means the 1000 milligram per nm cube is below 5 micron. Considering best efficiency of 90%, that means ESP in any case will leave 100 milligram. So what to do with this 100 milligram? So we have to come down from 100 milligram to 20 milligram on normal operating conditions. So there is a deficit of 80 milligram plus problem of soot blowing, problem of your wrapping, re-entrainments. So these are the issues which are there in front of us, and we need to resolve it to meet the future emission norms as well as to meet now the almost current emission norms of 30 milligram. So here the requirement, or I would say the MEPA, which can resolve the problem without disturbing the current operating condition or without disturbing the current profile of the plant. So how do we do this? Dry ESP you already have. We have to just add a polishing filter, which is called EGB, and convert it into a MEPA. So I will explain you EGB, which is a new concept for Indian industry. It's a beautiful concept. I don't think you must have heard it before, and I'm sure you need a little more energy to just absorb this concept. So what is EGB? EGB is called high efficiency filter or a polishing filter to remove very, very fine particulate matter below 2 micron, 0.1, 0.5 micron. It has a very good efficiency. So I will just explain you how it works. It is, let me first make one declaration. It is also an ESP of different kind. EGB is also electrostatic precipitation, but it is in vertical in nature, plus it has a reverse principle than normal ESP. So if you look at this, I'll try to point out if it is possible. No. Okay. So EGB is a cylindrical vessel wherein a thick bed of gravels, when I say gravel, it is a pure stone like pea gravels of 3 to 8 mm diameter. So there is a thick bed of gravels which you can see on the middle sketch. There is a bed of gravel which is being held, which is kept hold within the lowers. And these gravels are moving very slowly from top to bottom of the cylindrical vessel. And this gravel bed is embedded with discharge electrode case. You can see this electrodes here. And discharge electrode case is given a voltage, high voltage of 15 to 20 kV. So when the high voltage is given, and within this stone bed, you know the stone is a non-conductor of electricity, so it can't create a current. But it creates a static field around the gravel bed, and the gravels get a balanced charge. The half of the gravel gets a positive charge, and rest half of the gravel gets a negative charge. So this is called a process of polarization of the gravels. So when the particles escaping from your existing ESP is carrying a negative charge already, so when these particles passes through this thick gravel bed which is already electrified, so what happens, there are two types of separation which happens on this. One separation is because of the mechanical resistance which is created by thick gravel bed. And the second one is because of the electrical field, the negative charge particles stick to the positive side of the gravel. And whatever you get outside after that is a pure clean gas. I have seen the system running in Sweden for last 15 years consistently at 6 milligram per nm cube on a wood-based fired boiler. So what happens when the gas goes through this bed, it captures the particles even below 1 micron, 0.5 micron. It has a good efficiency. And gravel is moving from top to bottom, and there is a there is a vibro feeder at the bottom, and vibro feeder is VFD control. So you can increase or decrease the speed of evacuation. So more speed means less efficiency, less pressure drop. But when you decrease the speed, that means higher efficiency and little higher pressure drop. So there is a command already available in the system, and these gravels are coming outside the electrical field and then getting cleaned from a small gravel cleaner which is used through pneumatic air, and then used a dedusting cyclone for removal of that dust from the air stream, and air is put back into the system. And cleaned gravel also travels in a closed loop through a bucket elevator. So it is a completely closed loop system which defines and which, the gravels are not replenished only once in a while, 5 to 7% because of the frictional losses, whatever is there, that gravels are replenished online. So you just see, you can see on this video, this is a gravel bed. Can you run the video, Prakhar? I'm not able to do it from here. Possible? Okay. You can see this gravel coming very slowly from top to bottom. This is the speed. It takes one gravel to come from top to bottom about 6 hours time. That means there is a huge amount of retention time when the gases are passing through this gravel bed. And if you look at the efficiency curve, this is a demonstrated efficiency curve from our collaborator from USA. This technology is from MIT USA. Let me just clarify. And you find that up to 2 micron, the efficiency with voltage on is about 100%. Unlike in ESP, 5 micron also you have 90%. So there is a big gap in efficiency when you compare with the ESP. And then even with 0.2 micron, you have an efficiency of about 98%. Even with the voltage is off, suppose your TR set is gone because of some electrical fault, still you are having a very good efficiency. Up to 2 micron, you have a 90% efficiency. So this is the concept of EGB. And on the right hand side, you see how the gravels, ash coated gravels, are coming out from the system. This installation is done on a spent wash fired boiler in a distillery which has much more complex situation than black liquor. I will just compare the black liquor with a spent wash of distillery, then you would come to know. And then on the left hand side, you see the gravel cleaning. The gravel cleaning is by just putting the gravels outside the electrical field, the ash becomes loose, and with a little bit of air pressure and the mechanical flowing, the gravel gets cleaned. And then gravels goes up and back circulated. And you can see on the middle photograph, this is the type of flue gas. This is how the gravels are circulated back. So in the advantages, if you look, I'll just run through because of shortage of time. The advantages, if you see, it has a larger collecting surface area because each vessel has got about 120 tons of gravel. So if you calculate the total surface area of the gravel divided by 2, presuming that half surface of the gravel will not be used, though it is not true, 70 to 75% gravel area is used for deposition. The reason is that gravel is falling from top to bottom and gets turned. So whenever there is a other side sometimes become positive and sometimes the other side becomes negative. So the surface area is 10 to 20 times more than the ESP. Footprints are 1/5 of normal ESP for the same surface area. Pressure drop 60 to 100 mm, pressure drop across the bed. Power consumption is a bigger, most important criteria here because there is no current. So TR set power consumption is 0. We are only working through the voltage without having any migration or corona generation like normal ESP. And there is no wrapper re-entrainment possible here because the gravels are cleaned outside the gas stream. So there is no chance of wrapper re-entrainment during the cleaning of gravels going back to the system. And also the most important part is the resistivity of dust. In normal ESP, the resistivity, electrical resistivity plays a very important role in corona generation and migration. Higher the resistivity, poor is the performance. Here, higher the resistivity, better is the performance. Because we are not talking of current, we are only limiting ourselves to the voltage. So more resistivity, higher voltage, and better results. So this is a smaller footprint. There is no fire hazard because we are dealing with the stones. Even this has been used for clarification or purification of gases up to 700-degree temperature in glass furnace industries. So I'll take you through a small case study where in very short, the first installation in India on a spent wash fired boiler for DCM, Dorala Sugar Works. And a spent wash, if you look at the characteristics of a spent wash, you find, unlike in black liquor, here the input dust concentration is very, very high, 30 to 40 grams. And we were supposed to come down to 50 milligram, and it contains lot of potassium, up to 43%. So the nature of the dust is very, very fine. 40% particles are below 10 microns and such a huge quantity of dust. So it was quite a big challenge to address this. And this was the complete system which we supplied in 2020, and system is running for last 2 years successfully meeting below 50 milligram as per the design conditions. Even with the soot blowing in operation, you don't find any change in the emissions because of the gravel bed, which is acting as a positive filtration. There is, it's a pressure drop which creates this phenomena. How can we apply this concept? What is the replicability in pulp and paper plant? We have studied in last couple of months when we started engaging with pulp and paper industry. We find there are 3 areas basically. One is the CPP, because the resistivity of coal dust is increasing at the moment. Indigenous coal, temperatures 160, 150, the resistivity is higher, so it is difficult for normal ESP to capture those very fine particulate matter. So that is one area. And also after dryer, the blue haze issues are there. So that can also be area where this EGV can be applied. And plus, whenever you need a DSOX system, simplified DSOX system, the EGV can also be converted into a multi-pollutant system. We have a just with the gravel, we spray the lime and then reduce the SO2 also. Also with the gravel, we can put the activated carbon and reduce the mercury also. So this all two experiment on multi-pollutants are underway. We have done some experiment at Dorala and we have found a good reduction in DSOX, SO2. And the other area which, yeah, yes, I'll take another 2-3 minutes. Chemical recovery boiler is the very, very, the great potential for removing of that sticky nature of dust from these gravel filter. And of course, rotary lime kiln, though it is not yet explored, but there are chances of exploration on this area also. So as we move forward in pulp and paper industry, we would be taking up these projects maybe on trial basis in the beginning. Since the time is less, I'll just give you an analogy between black liquor and spent wash of distillery. In black liquor, the 8 to 15 gram dust and 30 milligram is the norms. And the particulate particle size, you see that 10 to 15% particles are below 5 microns. This is the comparison. You can run through. There is an article published in the proceedings. So you can run through and see all these graphs. The analogy between spent wash and black liquor, they are very close in terms of alkalis. One has got a high potassium, the other one has got a high sodium. And the typical characteristics are quite similar. So we are quite sure that it would be a breakthrough definitely on black liquor in paper industry. As I told you, on high resistivity ash, as the temperature goes, the resistivity goes up, and there also it can act as a catalyst for improving the efficiency of existing ESPs. And after you clean the gas to that extent, there is an opportunity exists to take some waste heat recovery by putting a small heat exchanger and then taking that heat and reducing the fuel consumption. That part is still to be explored, but there are chances in other industry people have done it already. So the major takeaway, I will just summarize the whole EGV part of it. The major takeaway, it is a very compact sizing. This can be fitted in the outlet funnel of existing ESP. So in most of the cases, there are no necessity of shifting your ID fan or shifting of chimney. In most of the cases, this will be within that range. It is capable of handling submicronic high resistivity particles, capable to reduce particles below 10 milligram if the situation arises in future. It is capable of reducing SOx and heavy metals also whenever there is a situation and norms demand that. No maintenance prone wrapping. In the ESP, the difficult part, I mean most of the people are only doing maintenance of this wrapping arrangement, which is very troublesome. Sometimes the hammer is down, sometimes the motor is not working. So here that is not there. There is no wrapping, it is only the flushing by air and then cleaning the gravel outside the system. So there is no wrapper re-entrament. So these are the major takeaway, and as a conclusion, we are trying this concept in paper now and mustard husk fired boiler, where again the properties are quite similar, and EFB in palm oil, empty fruit bunch. We have got a very good response from Malaysian market on palm mints. So wherever you find that there are complex nature of fuels, wherever you find there is a fuel mix, you cannot ascertain a particular resistivity of the fuel mix. Then going with an ESP, because ESP is designed for a particular resistivity. Higher the resistivity, efficiency is down. Whenever you have that confusion of product mix, not knowing the exact properties or the morphology of the ash, then attaching this will give you much better result, and it becomes a most versatile equipment, whatever technology we have as on date. So these are the applications. As I told you, you can just read it. Yeah. This is the company, so I'm not running this. We are located in Noida, I'll just tell that. And we are present in 24 countries, and this is our product range. Thank you so much. With the